In this video, we're going to cover fundamentals of accident investigations. The main topics we're going to hit are going to be incident response in a very limited way, evidence collection and preservation, the roots of causality, and report writing and documentation. So what do we think of when we think of an investigation? A lot of our minds probably go to TV shows that we've seen, like the old Dragnet show, Law and Order series, stuff like that, where there is an event. The people that are looking into that event don't fully have an understanding of what's going on, like say a theft, something like that. They don't know who did it, and they're trying to find out who did it, how they did it, why they did it, and how to catch them. In the news, you'll see the aftermath of investigations. Say a plane crash, the FAA and the NTSB will look into that, and you will see the results of that in the real world. So far, what you might be thinking is that the point of an investigation is to find out who's at fault. And what I'm going to challenge you to do here in this video is think beyond that and try to avoid the assignment of blame and look more towards causality. The goal in safety is a zero accident rate, meaning there's never an incident, there's never an injury. Everybody goes home the same way that they came in, every single day, no matter what, every single time. That's the ideal. In the real world, that's a bit unobtainable, but that's certainly what safety is striving to reach, is a zero accident zone. So what investigations into safety incidents should strive for is not necessarily assigning blame, but finding that causality, to find that linchpin that started the events that led to the accident, the injury, the illness in the first place. Fixing that issue will be the thing that moves you towards that goal of zero accidents. This video is going to break down investigations into 4 basic steps. While they're going to be sequential in this video, a lot of the times these things have a tendency to happen at the same time, all simultaneously. So keep that in mind as we move forward. Incident response. The occurrence of an accident rarely gives any time to really prepare, but incident response and preparedness is key to an effective investigation. Having a well-designed plan, trained and drilled response staff, and a culture of open reporting of accidents and incidents is one of the most important steps to effectively investigate incidents that starts well before incidents even occur. So we're going to go over some very basic principles of incident response, but we will not be covering that topic in a lot of detail here. Effective incident response is a whole nother topic unto itself. For the purpose of incident investigations, though, it is important to know a little bit about some of the human factors that are present during and immediately following an incident event. In any incident, there is some degree of panic for those involved and responding. An incident is an unusual and generally negative event, and it's human nature to do what I've found to be one of generally 3 things if you're not a regular responder to incidents. So if you're not a trained EMT, fire, emergency responder, that kind of thing, there are generally 3 types of behaviors that I've seen in lay people. First, there are the people that try to intervene. They may not know how to intervene, and they may not know what is appropriate or effective, but they're the ones that are the doers, the ones that see something and want to act upon it and very much affect its outcome. The second is the type of people that try to escape the situation, that immediately just run away from traumatizing or a difficult situation. And then the third type is the people that just freeze. They don't know what to do. They don't know how to react. And they either figuratively or literally freeze in place. As an investigator, you have to understand that each of these responses is absolutely valid and that no one really knows where they are on the spectrum until they're faced with the real thing. But understand that these factors can affect the investigation process a great deal. Think about how you might react if after a traumatizing event, an incident where you either were injured yourself or had an accident yourself or witnessed somebody that you've worked with for years become injured or have an incident. Think about how you might react if immediately following that incident or during the incident itself, some investigator walked up and began badgering you about the specifics of the incident and who's at fault and why did you do that, and your approach very much will determine the quality of the information that you get, especially during the incident itself and during the response period. Ideally, incident investigators should not be part of the actual incident response. That's certainly not the way things go in the real world, and in many cases, the incident investigator is also the person that is charged with the response to that incident. As we get into the real substance of this video, it is important to understand that there are a lot of dual roles that people play. Manager, incident responder, investigator, a lot of those things are the same person or the same individual. But understanding how you're interacting with the people involved at the scene of the incident is exceptionally important towards a good, honest, and effective incident investigation. Evidence collection and preservation. Effectively, this begins prior to the incident itself in a lot of cases. Things like machine settings, CCTV footage, logbooks, vehicle speeds, and other objective forms of information can be available and collected that shed light onto what led to the incident. For any investigator, knowing the basics of retention periods in particular is key to making sure that data that is available doesn't get lost. This is, again, something that is a lot of prep work. It's a lot of understanding your organization, understanding what's available in your organization, what kind of information is tracked, what isn't tracked. This will help formulate a lot of the remainder of your evidence collection, your questioning of witnesses, and quality of the information that you're going to get moving forward. From here, we're going to break down evidence collection, documentation, and preservation into two specific sections. At the scene. During the incident response and recovery period, there's not a lot of emphasis placed on the preservation of evidence, and nor should there be for the responders that are trying to deal with that incident. The immediate concerns are human safety, scene safety, and recovery, getting back to normal. But that period can destroy a lot of very relevant information. So we talked about things like CCTV footage already and other empirical forms of data. Don't rely on those forms of data to paint an appropriate picture of the scene itself. This is where a separation between the investigator and the responders can really come in handy. But even if that's not possible, training your responders to recognize and record, at least mentally, things like, was the weather involved? What was the weather like? Was there a specific odor in the area? That's especially important when you're talking about chemical spills and chemical related incidents. What about the physical scene itself is important? That's the things you're looking for at the scene and the types of evidence that will vanish very, very quickly. All the old movies where they put the chalk outline around the murder victim, that is an effort to preserve things that cannot be preserved indefinitely. While nothing hopefully will ever be quite that severe, that's the kind of thing you want to do with every note you take about an incident, every photograph you take about an incident, is describe that scene as if the person reading it will have never been there, will never go there, and doesn't have any understanding of the incident. You're trying to really paint a picture, and the information you gather at the scene will help you build that picture in the report that you end up writing. A few items of note with regard to technology that exists that allows for some extrapolation of information about the scene. Historic weather information is readily available online, but that information, remember, is based on a generalized area. Those generalized areas, as time goes on and as technology moves forward, are getting ever smaller, but it does not necessarily speak to the conditions at the incident scene. CCTV footage is another tool that is great in the investigatory process, but that shouldn't necessarily be relied upon to show fine detail. You can never really know what the camera caught at the event, whether it's going to be obstructed, if there will be some kind of an issue with the recording itself, what the resolution is on the cameras as to whether or not it's going to catch fine detail. So don't rely on CCTV footage to fill in blanks that you really need to be looking at the scene as it sat when you were there. Additionally, the recovery process for every incident should be documented as well. That's going to come into play in the final report, and we'll talk about that a little bit more when we get to that section of this video. After the scene. Following the incident and the collection of evidence at the scene, making sense or starting to make sense of what has been collected to this point should begin immediately. This will help preserve mental details in both the investigator and the witnesses and the people involved in that incident, and provide time for some follow-up before potentially the recovery process itself erases that information. But it is at this point that a deeper dive into the things not only that have already been collected, but things like organizational policies, training records, accepted behaviors versus trained behaviors, oversight and management of things related to the incident, equipment maintenance records, safety concern reports, near miss reports. These are the types of things that you can gather during this part of the investigation that really will flush out your causality as you begin the next section of this video. Roots of causality. All of the collected information, evidence, photographs, CCTV video, eyewitness testimony is in service to finding the cause of the accidents. Notice that I say cause and not causes. Often, investigators can rush to judgment and list a whole host of causes that seem accurate and viable. As an example, if a person falls down a set of steps in a parking lot, the causes could certainly be the stairs were ice covered, the person was wearing flat-bottom shoes, the railing was broken, and it was dark in that portion of the parking lot at the time. But these are symptoms of the actual cause or the root cause. CollinsDictionary.com defines root cause as the fundamental reason for the occurrence of a problem. In accident investigations, this is the actionable result of the investigative process if the goal is to reduce or eliminate the potential for a similar accident to happen again. Remember, the goal for health and safety professionals is that 0% accident rate. There are many tools that help investigators find a root cause. One of the most effective and often cited is the 5 Why method. This video won't go into the origins of the method, and it does have broad usage across many other disciplines. In fact, it came from the auto industry. That's my only little bit of history that I'll give on it, just to not make this video 3 hours long. But it's highly effective for health and safety professionals in getting to what actually caused accidents and helps create very effective corrective actions in the final report. Let's take the established example of the person falling down the steps. The initial answers to the question why remain the same at the surface. The stairs were ice covered, the person was wearing flat-bottom shoes, the railing was broken, and it was dark in that portion of the parking lot at the time. But for each of these answers to the question why at the surface level, there is a second why that can be asked. The stairs were ice covered. Why? Because staff had not yet applied ice melt after a storm. The person was wearing flat-bottom shoes. Why? There was a VIP event that day and the individual was wearing dress shoes. The railing was broken. Why? The railing was snapped at a rusted out weld. It was dark in that portion of the lot at the time. Why? Parking lot timers had not yet been reset for daylight savings time. Some of the answers to this level result in dead ends. For instance, why was the individual in dress shoes? Very simple, because of the presentation that morning. Others generate further why questions that need answers, and some may even begin to converge on a single answer that encompasses more than one question. The stairs were ice covered. Why? Because staff had not yet applied ice melt. Why? 3 of the 10 maintenance positions in this particular location are unfilled. The railing was broken. Why? The weld had rusted and snapped. Why? 3 out of the 10 maintenance positions are not yet filled. The parking lot lights had not yet been reset. Why? 3 of the 10 maintenance positions are not yet filled. In this simple example, you can see how the answers to the questions why, as we move down the levels of questioning, are starting to converge on one single answer that may be our root cause. It can be fairly easy to stop right here now that we've had multiple answered why questions that end up pointing to the same cause. But we're going to go a step further and find the root cause. Why was the lack of 3 positions out of 10 in maintenance not being filled lead to these conditions? The 7 remaining staff were forced to cover the workload of 10, and priorities had to be placed on projects and issues based on need. So what is our root cause? A shortage of workers in maintenance led to the conditions that ultimately resulted in the employee falling down the stairs that morning. There are certainly other why questions that we can continue to answer based on this result, but for the purposes of a root cause analysis and the investigative process and the report that's going to be generated from this and the action items that are going to come out of this, this is right where we want to be for our root cause. Now consider your 5 whys might end up being 2, might be 1, might be 10, might be 15. It really depends on the complexity of the incident and the type of information that you have and the circumstances surrounding it. So the 5 whys is really a title, so don't get caught too much up in that verbiage. But the process is meant to ensure that the investigative process and the investigator is looking as deep as is appropriate and necessary to really find the point where the problem started that caused that incident. Without that determination, you're putting band-aids on symptoms of an underlying problem that has not yet been identified and cannot be solved. And if we don't identify that problem, there's no way to prescribe solutions to ensure that a similar incident or that the issue doesn't crop up again in the future. And that is the whole purpose in investigating incidents in such a regimented fashion. Reporting and documentation. Investigation, evidence gathering, determining the root cause, none of this is of any real value without adequate reporting. Effectively communicating the results of all of this is paramount towards the, again, goal of a 0 accident rate and towards prescribing and following up with any corrective actions that might be appropriate given the incident. There are many templates available online. Insurance companies and underwriters generally have their own formats that they want to see reports. For the United States in particular, the Occupational Health and Safety Administration also provides templates that can be very useful in ensuring accurate and compliant reporting to the Department of Labor, and is a good place to start. Aside from that, reporting should at least include basic information like the time and date of the occurrence, the time and date of the report, those directly and indirectly involved, the location, a narrative of the occurrence itself and its circumstances, a cataloging of the information and evidence collected, along with where it is being preserved and the methods used for collection, the root cause and supporting information leading to that determination, the direct and indirect costs of the incident, including sustained injuries, property damage, impact on productivity or similar regulatory exposure, etc. And most important, corrective actions. Corrective actions from the standpoint of risk control and hazard mitigation are the linchpin of effective incident investigations. An effective incident report should document the answer to this one simple question. What do we do to keep this or something similar from happening again? Clear, actionable, and reasonable corrective measures not only create a path toward the goal of a 0% accident rate, but also demonstrates the organization's commitment to that ideal upon their implementation. So here we are, a completed investigation. What do we do with it now? Follow-up. Without appropriate follow-up following an incident investigation, corrective measures, there really isn't much of a point to doing it in the first place. Safety is a continuous process of improvement, and the results of incident investigations should be taken as an opportunity to improve. Incidents are events that no one ever goes out expecting, and accident prevention and hazard detection are entirely different topics altogether. But when incidents occur, the best thing for any individual or organization to do is objectively look within and determine what can be done better moving forward. To return to a point that I made earlier in the video, you'll note that at no point did the process look to assign individual or individuals blame. Blame is the act of assigning responsibility. There is certainly a place for that, in particular in legal and regulatory proceedings, but this process is about cause, not blame, and admittedly, there are times when this process may assign blame to individuals, but this should be done exceedingly rarely, and only after exhausting all other potential causes. Finding and mitigating causes is a path forward. Blame looks to the past. This has been an admittedly brief overview of the investigatory process with regards in particular to safety incidents. There are whole courses that teach this in much more detail than what I've gone over here from a lot of different perspectives. For instance, an insurance investigation has a whole different focus than an internal investigation. And really what this video is meant to do is give you a good idea from an organizational standpoint what you should be doing when you do encounter incidents. I hope you found this informative, and I'd really like to hear from you in the comments below. Thanks for watching, and remember, life is risk. Manage it well. When I was 15 and I started my very first quote-unquote real job after being a paperboy, one of the first things I was taught by management has stuck with me to this day. As the story was told, the morning maintenance/cleaning person at a competing restaurant chain was found deceased in a tiny storage closet when staff arrived a few hours later after he started work alone in the morning earlier that day. The investigation into his death revealed that he was mixing an industrial grease cutter with chlorine bleach, preparing to mop the floors. The mixture had basically created mustard gas, ending his life before he even realized there was a danger. This is not an isolated incident. The exact same incident still happens occasionally, and it shouldn't. 29 CFR 1910.1200 is the hazard communication standard under federal law. More commonly, it is known as the right to know. The standard explains the requirement that, at its most basic level, those that work have the right to know under the law about hazardous substances, including that they exist in the workplace, how they can be exposed and what the hazards are, how to safely work with and around them, and specifically how to protect themselves. It is important to know the standard and to have a working understanding of its requirements before any organization sets up its hazardous communication program. It's also very important for workers to have an understanding of the standard as well. Hazard communication is among the top 10 OSHA violations year after year. Between 2021 and 2022, exposure to harmful substances or environments resulted in 600,000 cases of both days away restricted or transferred and days away from work, and kills an estimated 50,000 workers annually in the United States alone. Science and industry constantly innovates, creating new materials, chemicals, and processes that employers and workers need to keep up with to maintain safe facilities and working conditions. The next section of this breakdown will discuss the identification and classification of hazardous materials. Hazardous chemicals are substances that can pose a physical or health risk. Great. How is this determination made? Chemical manufacturers or importers are required to determine the hazards of the products they distribute using CFR 1910.1200, Appendix A and Appendix B. This must occur both when creating something new and anytime there is a change made to the makeup of a chemical or other product. This video is not intended to detail the process of hazard classification, but it's important to have a basic understanding of how classifications and hazards are determined, so I encourage you to take a look at Appendices A and B for more information. Once these determinations are completed, the next and most ubiquitous tool in hazard communication, the safety data sheet, can be authored. Safety data sheets, or SDSs, are the primary way that the hazards of materials are communicated from those that produce them to those that work with them. Before we go too far down this path, though, it's important to make a quick note. For the majority of the existence of the hazardous communication standard, the Material Safety Data Sheet, or MSDS, was the expected format. Due to a number of challenges with that format, the United States adopted the SDS, aligning with the globally harmonized system of classifying and communicating the hazards of chemicals. Among other things, GHS standardized much of the methodology, terminology, labeling, and formatting of chemical hazards all over the world, effectively eliminating confusion based on individual country or regional standards. The most obvious manifestation of this move is the humble SDS sheet. To save time in this video, I'll lay out the sections of an SDS and go over them in detail in another dedicated video. I will highlight that for most individuals, the most important sections, especially in an emergency situation, are Sections 4, First Aid Measures, and Section 8, Exposure Controls and Personal Protection. The 16 sections that must appear on every SDS are Section 1, Identification, Section 2, Hazards Identification, Section 3, Composition and Information on Ingredients, Section 4, First Aid Measures, Section 5, Firefighting Measures, Section 6, Accidental Release Measures, Section 7, Handling and Storage, Section 8, Exposure Controls and Personal Protection, Section 9, Physical and Chemical Properties, Section 10, Stability and Reactivity, Section 11, Toxicological Information, Section 12, Ecological Information, Section 13, Disposal Considerations, Section 14, Transportation Information, Section 15, Regulatory Information, and Section 16, Other Information. So now that we know a bit about SDSs, let's break down the responsibilities for their production and distribution. The manufacturer or distributor of the material is responsible for authoring SDS sheets and ensuring that their contents are complete and accurate. From here, the SDS must accompany that chemical as it moves through the supply chain to its end users. To clear this up a bit, if I am the producer of a base chemical, say sodium hypochlorite, I am responsible for authoring and distributing the SDS for that substance as I supply it to the manufacturers of household bleach. Once the bleach is manufactured, that manufacturer is responsible for authoring and distributing a new SDS as the new product is supplied to, say, a retail outlet. Distribution to workers. In the case of the producer of the NaClO, they must distribute or make available the SDS for that substance to its affected workers, visitors, vendors, or contractors. In the case of the bleach manufacturer, they are required to distribute the SDS for both the NaClO and their bleach product, as both would be on site during manufacturing. In the case of the retail outlet, they're required to distribute the SDS for the bleach to the workers, visitors, vendors, or contractors at their facilities. There have been a variety of acceptable ways to accomplish this, and I'll quote directly from a 2012 OSHA brief here. Employers must ensure that the SDSs are readily accessible to employees for all hazardous chemicals in their workplace. Without going too far down this rabbit hole, when thinking about your SDS database, consider things like technological failures, power outages, internet downtime, and other factors when choosing how to make your SDSs available. Items of note. If relying primarily on digital distribution, it is key that there be devices available that employees can easily locate and that are accessible without any form of passcode at each facility. There should never be any sort of barrier to an employee accessing an SDS while on site. Also consider accessibility to emergency responders. In particular, fire and emergency medical responders will need ready access to information contained in SDSs. During a fire, this information is vital to the safety of the firefighters, and EMS responders will be able to more effectively treat exposure incidents with appropriate SDSs. So how do I know if I need an SDS? SDSs, as we've already discussed, are required to be provided by the manufacturer or importer at the point of sale, shipping, delivery, so most likely you'll receive one with each order or shipment. However, it's good practice for downstream employers to check for SDSs for each chemical at the time of purchase, in particular if it's something you've not acquired in the past. This includes consumer-grade chemicals meant for or purchased at the retail level. Consumer-level labeling and other paperwork may not satisfy the requirements of the Hazard Communication Standard. Why not? Think of the glass cleaner you keep at your home. How often do you use that cleaner and for how long? How much of it do you have stored? There's a different exposure risk presented when chemicals are used at work. At home, you perhaps clean your windows once a week, but a worker at a window washing service uses that chemical every day, all day. Additionally, there's a different risk when a product is purchased and stored in bulk. Take the glass cleaner example and consider a product that contains ammonia. One bottle in a building may not be an issue during a fire, but 40 bottles may just pose an increased risk to firefighters. There are also risks associated with storage of different chemicals and how they might react to each other if accidentally combined. This delves deep into product safety management and is a topic for a whole nother video, but it is a good point to make. Again, it's good practice and policy to require all chemicals to have an SDS sheet before being brought into the workplace, regardless of how long it will be there and its scope of use. It's easy to bring in one container as a trial or for a narrow use case and have 100 before too long, creating a potential regulatory exposure or a risk of an existing chemical becoming mixed and producing a toxic substance or other unforeseen set of circumstances. Another key point is each SDS must be current, which leads to the next topic, SDS auditing and updating. How often are SDSs updated? To take our previous example, if the producer of NaClO makes a change to their product by, say, changing the formula to be NaClO2 for whatever reason, they must alter their SDS accordingly, subsequently requiring the manufacturer of the bleach to alter their SDS, passing it along to the retailer and thereby making it available to their workers. All this should be completed in advance of moving the substance along in the chain. In a perfect world, that would make ensuring that the most updated SDSs are always available at all times very easy, but reality can sometimes throw wrenches into the gears. The easiest way for employers to ensure that SDSs are available and are current is to create an auditing regimen. In fact, there are a lot of third-party SDS databasing companies that provide this service to employers for just this reason. But however it's accomplished, best practice is to audit the contents of an SDS database at least annually, but a more frequent periodicity may be prudent depending on the specifics of the organization. For instance, the bleach manufacturer may make many products that are comprised of a lot of different chemicals, and they may want to audit monthly to cut down on potential issues more frequently than once a year. But just know that no matter the audit schedule, 29 CFR 1910-1200 requires that SDSs be up to date at all times. If it's on site, the SDS must be current and easily accessible. So are there any requirements for training employees in all of this? Absolutely. I'll begin with the most basic quote from the standard. 1910.1200 H1. Employers shall provide employees with effective information and training on hazardous chemicals in their work area at the time of their initial assignment and whenever a new chemical hazard the employee have not previously been trained about is introduced into their work area. Information and training may be designed to cover categories of hazards, i.e. flammability, carcinogenity, or specific chemicals, Chemical-specific information must always be available through labels and safety data sheets. There are more specific requirements listed throughout the full standard, but this is the most basic criteria for training. The training must consist of the requirements of 29 CFR 1910-1200, even if certain sections don't apply or seem to apply, the employer's written HAZCOM program, where in the operation hazardous substances are used, stored, or located, how to access SDSs, detection methods for accidental release, how to recognize them and what to do, the specific hazards of every substance, personal protection methods and requirements, how hazardous substances are labeled at all points of the operation, shipping, receiving, point of use, etc. The regimen of these training requirements is baked right in, but has some nuance. We'll start with a worker brand new to the facility. Before they are assigned work or work in an area potentially affected by a hazardous substance, training in these areas must occur. Logistically, a good time to complete this requirement is as part of the onboarding process. Following that, training must occur for each new hazardous substance introduced or that a worker is exposed to over time, and if updates occur to the substantive contents of an SDS. If there are no practical changes for workers, update training may not necessarily be required. What does this actually look like? It depends a lot on the organization, the potential risks based on the chemical inventory, and many other factors, but there is a key phrase in the standard and many other OSHA standards, and that is effective training. So what the hell does that mean? It means that employers must ensure not only that their hazard communication program is adequate, they also must ensure that each employee exposed to hazardous substances understands and follows the provided training. I'll provide an example. Let's take an employer that provides residential cleaning service and completes HAZCOM training with a new employee that is thorough and even includes a comprehensive test at the end, and the employee gets 100% on that test. The employee has been on the job 2 months and one day gets a caustic tile cleaner in their eye while at a job site due to not following the PPE requirements of chemically protective goggles. Would the training be considered effective? That's a hugely speculative question given this example, but I'll make this point. It's up to the employer to ensure that the training is effective, not the employee. So without an adequate follow-up and oversight, the training's effectiveness cannot really be determined. I say that to say this. Evaluation of the effectiveness of safety training is a continuous exercise, and assuming that employees are following, in this case, hazard communication training and PPE requirements simply because they attended training is arguably inadequate on the part of the employer. I'll look forward to a constructive debate on this point in the comments for sure. So, who needs to be trained in hazard communication? Well, the short answer is everyone, to a degree. This is open to some debate as well, but in my experience, there's rarely a worker from the 2-week HVAC contractor fixing the heating system to C-suite executives that doesn't come in contact with this standard in some way. Anyone that enters a facility is subject to the same potential hazardous substances, regardless of status. And I can't think of a facility that doesn't have some hazardous substance risks, even office buildings. Perhaps the training doesn't need to be as detailed for these folks as it would be for the workers that actually handle the chemicals, so it can be tailored a bit. But if there is no training and there is an exposure incident, the absence will certainly be an issue.
You're gonna have a bad time.
A best practice is to make basic HAZCOM training part of an overall safety onboarding for all employees to ensure that there is a baseline understanding of the employer's program and 29 CFR 1910-1200 in general. More robust training can be reserved for those with higher degrees of risk exposure. So has this video been HAZCOM training? Partially, yes. This video has covered many of the main topics required, and so do off-the-shelf training programs that are available for purchase. but there will always be employer-specific items that must be tailored for the organization, facility, and in most cases, the tasks being performed that generalized training will not satisfy. Keep this last point in mind when designing a hazardous communication training program. I'll leave this topic for now with these last thoughts. HAZCOM is a very core standard in my opinion. There are so many other standards that overlap with HAZCOM and that are dependent on HAZCOM that to overlook it or underestimate its importance or severity is a disservice to an organization and to those that work for it. I hope you found this helpful and it gave you a better understanding of how to begin crafting your hazardous communication program. If you could take a moment to like and subscribe, it would really help out such a small channel reach the right places. And remember, life is risk. Manage it well. I wanted to keep the bulk of this video succinct, but an explanation of GHS pictograms is just too important to omit. Hazardous chemical labeling is its own special kind of confusing at times, but I wanted to highlight the GHS system of labeling. For the average worker and workspace, these labels are, in my opinion, the clearest for workers to understand and the easiest for employers to implement. The 5 sections are easy to fill out with the use of the chemicals SDSs and can be adapted to most types of containers without too much trouble. Additionally, the pictograms used by GHS are, by definition, global and offer the broadest comprehension even where there are language barriers. Thanks again for watching. In the world today, one thing we take for granted is the simplicity and ease at which we can take photographs of the world around us. It wasn't all that long ago that the now simple act of taking a picture took a bit of skill to ensure that what you were trying to capture was captured when the film was eventually developed and returned. Even as the availability of affordable consumer-grade digital cameras became common, actually having a camera with you every moment that could take high-quality pictures in any lighting condition has only really been a thing since the introduction of high-megapixel smartphone cameras and the efficient LED flash. I say that to say this. There's virtually no excuse for not having good, quality photographs of incident scenes, but I've found their absence is still a challenge in reports that I've read, even from some seasoned investigators. At times when pictures are taken, their usefulness can be challenging. In this video, we'll discuss how to take effective pictures at an incident scene, how to catalog and present them, and ensure that they are archived appropriately. The intent of incident pictures. I talked about painting a picture of the incident scene in my Fundamentals of Incident Investigation video, and one of the best ways to do this is through actual photographs. But the phrase, "a picture is worth 1,000 words," is only a half-truth in this context. The intent of incident photography is to capture not only images of the scene, but of the action of an incident in static images. The images must represent the details of the incident you're trying to capture with the least amount of narrative explanation as is possible. Scene picture composition. It will seem rather obvious that to take an effective incident picture, just take pictures of the scene. But how those pictures are taken makes a big difference. These pictures certainly capture the scenes of these accidents, but how useful are they as an investigative tool? Do they show detail in the extent of the damages? Do they show the positioning of relevant objects in the scene to each other? Not really, but these are good photographs. This picture certainly shows the detail of the damaged property, but no context surrounding it. Could you tell what this was, even if you had no familiarity with this type of machine? Could you tell what this picture was trying to describe about the incident? It's important when taking pictures to take both establishing shots of the scene and fine detail shots, but also a lot of intermediate shots to add context. These shots help to forge a much better explanation of the scene together, where individually it may be difficult, not necessarily to tell what you're looking at, but why you're looking at them in the first place. Actual picture quality. One of the luxuries we have with available technology is the ability to preview pictures instantly as they're taken. Do this. Don't just assume that what you're seeing is what's actually captured in the photograph. Lighting conditions, automatic camera settings, and a whole host of other factors can dramatically affect the resulting captured image. The most readily available cameras, the ones on our phones, have a lot of settings that are meant to make taking nice looking vacation photographs and selfies easy, but can make taking effective evidence photos challenging at times. Now, I'm not a professional photographer, so I'll leave the science of photography to those more qualified, but you don't need to be a professional to take good incident photos. As long as you're reviewing your photos and making sure that the image is of sufficient quality that you capture what you want, that's good enough. If possible, it can be helpful to have a dedicated camera that's set up for taking incident pictures, but the logistics of having that camera available can be challenging. The ubiquitous availability of phone cameras is generally the best option. Archiving. This may go without saying, but I'll say it anyway. Offload your pictures as soon as possible. Relying on the device storage alone leaves your pictures vulnerable to a whole host of potential ways to lose them, especially in the chaos of an incident scene. The best option is automatic upload to cloud storage on a network, but if this isn't feasible, ensure that all files are offloaded to a stable and backed up storage system as soon as possible in a way that will preserve any metadata captured along with the photograph. All files should be able to demonstrate that they are original and have not been altered to preserve their integrity as evidence. An item of note: if relying on personal devices for incident pictures, attention should be given to retention policies on those devices. Consult legal professionals for guidance, but the use of personal equipment may expose those devices to legal discovery. Use of photographs and reports. All photographs should be cataloged individually in any written report of an incident by file name, general description, date and time the picture was taken, and where it is stored and archived. It is likely that there will be more pictures taken than what will be used directly in the final report, so this list is essential to ensure that all photographic evidence is notated and communicated. Aside from that, directly embed photographs into reports wherever possible. The use of reference photos in actual incident narratives can be exceptionally helpful in painting that picture of the occurrence in the minds of those that read the report. When used in this way, it can be okay to make some alterations to the photos to highlight what you're describing in words. For instance, cropping, adjusting contrast, exposure levels, zooming, not zoom and enhance.
Enhance. Enhance.
Just print the damn thing!
And other after edits, when used sparingly, can be very useful in completing the final report. Be sure not to alter the originals and keep copies of the edited photographs along with the originals. This will maintain the integrity of the originals and demonstrate transparency in how they were used. One quick note as we wrap up. Videos can be a great tool to show a lot of detail of an incident scene, but they don't take the place of still incident pictures and shouldn't be used to pull still images from. Things like motion blur and steadiness can affect image quality if still frames are cut from a video, and video resolution is of lower quality than still images on many devices. Taking effective incident pictures is a nuanced skill that takes time and practice to become proficient. It is very helpful for investigators to practice this skill as often as possible outside of an active incident and to take time to look at pictures taken by other investigators in real-world scenarios. One easy way to practice is to find a benign situation, attempt to tell the story of that situation only in pictures, give those pictures to a colleague and ask them to tell the story that they see in those pictures. A sort of photographic telephone game. Hearing the story of your pictures from another will help refine your technique. Incident scenes change very quickly, and knowing what's useful and capturing it quickly and accurately can make a huge difference in creating a safer environment. I hope you never have to take incident pictures, but if you do, I hope this video has given you some pointers on how to do that effectively. I hope you found this video informative, and remember, life is risk. Manage it well. When was the last time you thought about your vision? Seriously, for the majority of us, we probably take our vision for granted until we start having problems. Degradation of our vision can be so slight that it might take a long time to recognize that there is an issue, and it's such a common symptom of age that we probably rarely even think that the cause is anything other than that, less some form of illness or trauma. But take a moment to think about how delicate and sensitive your eyes are. Small, fluid-filled sacs under about 20 millimeters of mercury of pressure, relatively loosely set in the skull, facing nearly every new condition or obstacle you encounter. Now, they've evolved some fairly good protections in the form of strong and sturdy eye sockets to protect them from blunt trauma, eyebrow ridges and hairs to send liquids around the eye, eyelids and lashes to keep a lot of fine particulates from damaging the lenses, and tears to wash out foreign matter quickly. We've even developed instinctive reactions to turn away from bright lights and harsh winds. All of these protections are reactions to natural hazards in the environment, but we started removing ourselves from our natural habitat as soon as we figured out how. All things being equal, this would be great news for our eyes and eye health in general. But in the place of what we're avoiding, we've installed new ways to damage our eyesight. For instance, have you ever had an MRI? There are a ton of questions that they ask to ensure that the machine doesn't cause any damage to you, mostly about your relationship with metals. But one question that will send you for a head x-ray is, have your eyes ever been exposed to metal fragments? Now, I won't go into the particulars as to why they ask that question, but answer that question for yourself. I'm sure you could probably remember a time when someone somewhere was using an angle grinder or a hand file and your eyes were unprotected if you haven't done those things yourself. This is what I mean when I talk about all the new ways we've invented to damage our eyes. As a responder to counted but countless calls for medical assistance of varying severity and situation, I've always taken special care with injuries and trauma to, around, and about the eyes. But oddly, I've had to use a lot of words to convince those with eye injuries, contamination, or other issues to seek follow-up medical care, and even more words to explain why requirements for eye protection of various types is so important. Few could offer cogent arguments against eye protection, but it's still one of the most often willfully skirted safety requirements I've encountered. I've watched as people timidly slide their glasses on as a manager or safety professional walks by and slap them off immediately once they're out of view. I would imagine the internal thought is something like, what are the chances something's going to go directly into my tiny eyeball? We'll start there with a few stories. The first is during my time in the hospitality industry. It was a common practice for housekeeping staff to store their spray chemicals on the handles of their room carts while cleaning rooms. One day, an experienced housekeeper was pushing their cart down the hall and hit a wall, causing the spray bottle with a very acidic tile cleaner to discharge across the cart directly into their eyes. The next story is of a worker who was attempting to secure two pieces of plastic with a type of superglue while assembling part of a machine. When the pieces snapped together, excess glue shot out from between each piece directly into their left eye. Lastly, a maintenance worker was performing routine checks on a production line that consisted of low-pressure chemical dispensing equipment when a hose clamp failed. Portions of the hose clamp struck their eye socket directly above their right eye. Eye protection was only required in the last of these three examples, but was not being worn. In the first example, the chemical was quickly phased out for something much safer, and the second resulted in eye protection requirements being initiated. These are just three of the issues that I have directly dealt with, and a tiny fraction of the nearly 20,000 annual severe eye injuries reported in the US alone. A side note, due to the way that OSHA and the BLS tabulate eye injuries in the United States, the data focusing more on the loss of vision or the physical loss of an eye, it can be difficult to truly assess in the data how many incidents involve more minor or cumulative injuries to the eye or degradation of vision over time. I say that to say this. Cumulative damage to the eye can be just as destructive to the overall health of the eye as episodes of trauma. I'm certainly no optician, but it doesn't take a massively wrinkled brain to work out that if you have 10 corneal abrasions over 20 years of metalworking, that it's fairly likely that you're going to start having some vision issues, all other things being equal, of course. The same might go for individuals exposed to UVB light sources over a career curing adhesives or paints, or those that stare intently at a computer monitor all day, every day. Another side note here to state the obvious that medical checkups are paramount towards health in general, eye health being no different. So, what do we do to protect our vision for the long term at work? Well, I already mentioned one of the most common forms of eye protection earlier in this video, protective eyewear. This generally takes the form of commonly required safety glasses that are usually intended to protect the eyes from impact damage from debris, but that also provide protection against heat, nuisance dust, radiation, and liquid or chemical splashes under the ANSI Z87.1 or Z87.1 Plus standards. If you're interested in knowing more about the testing process to achieve compliance with this standard, check out the link in the description. Even though I'm not going to go into the minutiae of the standards here, I'll make this point because I've had to make it many times. Not all glasses are safety glasses. The general prescription eyewear and readers, what I'll call regular glasses, worn for vision correction, provide little to no performative protections against these hazards and can cause more severe damage to the eyes in some instances. Here's why. The lenses and general constructions of regular glasses, when struck, can shatter into small pieces that become dislodged from the frames, forcing not only the original object, but the glass itself into the eyeball. Let's face it, glasses are a fashion accessory. Sure, prescription glasses correct vision problems, but when choosing frames and overall design of glasses, this is a highly individualized choice, and most of us go for looks over function.
Oh man, they look nice. I had a pair just like them.
Well, after the game, I'm gonna pick out a pair that's more me.
Good luck.
They look good. Besides, seeing's the most important thing, son. I don't think it's that important.
This means that what we're wearing probably won't adequately protect the eyes from splash or nuisance dust. Without wraparound protection above and below the eyes, there's a good chance that a splash of chemical or dust will still get into the eyes. This is the type of safety glasses that most everyone seems to be able to get behind. Who doesn't love a good pair of sunglasses, right? Especially when you work outside for any period in the sun. This is not the only use case, though, for radiation protection. UV light is used in a variety of ways in industry, and UVB in particular can cause significant issues over both short and long-term exposures, and there's a specific class of safety glasses for those cases. I won't even get into safety eyewear for heavy environments like caustic chemical production, welding, hazardous materials cleanup, or biohazardous environments. This video isn't an ad for all the different types and combinations of safety glasses. My point is to demonstrate that eyewear isn't just for correcting vision, and we have no issues wearing some types of protective eyewear. Probably none of us have a problem with voluntarily and happily putting on a stylish pair of shades. So why then can it be so hard to get us to wear safety glasses? Simply, they just don't look cool. But imagine your life without vision. No more TV, no more gaming, no more watching the seasons change, no more watching your kids grow up. Whether or not it's a requirement where you work, be aware that some of the hazards that can affect your vision may not be all that evident or common, but they exist. Many workplaces require some measure of eye protection, but it would be a good bet that not a single one would ban it. No matter what eye protection that's required or that you choose to use, emergency eye wash stations are still imperative in areas where foreign matter may still enter the eye. Their requirements, best practices, and the regulations that govern them warrants a dedicated video, but I'll make a few points before we wrap up this video. There is no substitute for plumbed eye wash stations. Bottle stations, portable stations, and others that are on the market seem like a good option, but they're not approved by regulatory agencies for a lot of very good reasons. Simply stated, an emergency eye wash station must be supplied with a constant supply of clean, fresh, tepid water. Even plumb stations need to be regularly inspected and maintained, so imagine what that bottle station's water would be like to spray into your eyes after it's been on the wall for a few years.
Definitely an OSHA violation, that's for sure.
Oh, absolutely. Everybody's getting sued.
Again, I'll go over these requirements in an upcoming video, but keep your eyes out for these items in your workplace and where adequate eye wash stations are located in your facility. Eye protection exists to help you keep your vision clear, but they are your eyes. Let them show you a clear and vibrant view of the world around you as long as they can. Hello everyone, and welcome to another nearly exciting video. As promised in a recent video, today I'll be covering the hierarchy of controls. This is one of the bedrock principles of safety in general, and is just about the most important tool in gauging the effectiveness of proposed mitigation efforts when workplace hazards are identified. Safety is never absolute. I've jokingly said if no one ever left the house and lived in hermetically sealed hamster balls, we wouldn't have to worry about hazards and risk would be something only talked about in history textbooks. But who would ever really want to live in that world? So we all wake up each day and face the risks of walking down the stairs, going to the store, attending school, or completing a shift at work, mostly aware that something bad may happen at any moment, but that it usually won't. This doesn't mean that we don't recognize hazards in our environment. We wouldn't have survived to this point otherwise. I would argue that one of the most defining characteristics of survival is being able to recognize risks. The second is how to react to them. So here we humans are, at the top of our game, building civilizations for thousands of years, all the while identifying and cataloging the risks we faced along the way, and getting to the point now that many of us don't even have to think about even identifying risks anymore. Many of them have practically been eliminated to one degree or another. For instance, when was the last time you had to personally identify the signs of risk associated with the weather? Weather forecasting and alerts are so commonplace that people get upset when a swimming pool is shut down due to the impending threat of lightning. This, though, is not a video about how to identify risks and hazards. That will come in a different video. But how to go about minimizing that risk where it's found in the workplace. Hell, this is also very useful outside the workplace too, but I digress. Just for a little bit of history, in 1950, a full 2 decades before OSHA was formed in 1970, the National Safety Council introduced their system of reducing workplace hazards, the hierarchy of controls. Starting at the top with the most effective and moving towards the least effective, it consisted of elimination of the hazard outright, substitution of the hazard for less hazardous options, engineering controls of the hazard, administrative controls of the hazard, and personal protective equipment implementation to protect from the hazard. These may seem a bit self-explanatory, but I'll give some examples of each based on a simple scenario I've used in a previous video. The hotel housekeeping employee that accidentally sprayed a caustic tile cleaner into their eyes. Keep this scenario in mind as we move down the pyramid. Elimination of the hazard would be fairly obvious, but does come with some analysis. A question in this case could be, and was, do we really need to clean the tile at all? Stopping the activity that introduces the hazard would certainly eliminate the hazard. I've seen this happen in the real world, but it is admittedly rather rare for legitimate tasks. It's kind of difficult to stop doing something that is necessary to function as a business or organization. Substitution for a less hazardous option is a quite often overlooked but highly effective solution to many hazards. If you watched my video on eye protection, you already know that this was one of the solutions to our example scenario. In that case, the caustic tile cleaner was substituted out of common use for a much more mild cleaner for general use. Just as a quick note here, substitution is substitution for a less hazardous option. Does not remove the hazards. Another, maybe less significant hazard is installed in its place, but that hazard also needs to be addressed and mitigated in exactly the same way as any other hazard. Engineering control is a solution to a hazard that basically physically separates employees from hazards during normal use cases. Common example of an engineering solution is in biohazard isolation chambers, both in real life and that we've all seen in movies and other media. Another very effective example of this that I've seen employed is in the realm of taking water meter readings. Historically, this generally required an individual to descend an underground access hole to visually read a meter installed on the delivery equipment from the water company. In many cases, this is a confined space entry, and of those times, it's a permit-required confined space entry, exposing employees to a laundry list of potentially fatal hazards if not properly executed. As technology advanced, it became possible to read meters from meters away wirelessly. Heck, before that, there were ingenious solutions as simple as a digital camera attached to a pole, engineering the risks associated with confined space entries completely out of the equation. Administrative controls can take many forms, but basically is the creation of workplace rules, standard operating procedures, and policies surrounding the hazard crafted to prevent employees from being exposed to them. For instance, in the original example of the tile cleaner, it became policy not to have the caustic tile cleaner on the housekeeping cards. If it was necessary to use, it would be retrieved from a chemical storage room, used, and replaced immediately following to limit the exposure risks the chemical presented. Personal protective equipment is the final protection considered when all other control methods aren't feasible. PPE is its own series of video topics, but for the sake of brevity, and with respect to the tile cleaner example, in the instances where it must be used, adequate PPE was mandated to protect from the hazards presented by using the chemical. Each of these controls do have their drawbacks. Elimination of the hazard may limit productivity in one way or another, as can substitution. Engineering controls can be expensive to implement in the short term or be impossible given the particulars of how the hazards present themselves in practice. Administrative controls rely on good, effective training, oversight, and the willingness and ability of each individual to comply with the controls of the policies. PPE is often uncomfortable, in some cases expensive, cumbersome, or unavailable, and in some cases may add additional hazards like limited visibility or dexterity that require additional controls and analysis. Even with the drawbacks, over the 75 years since the introduction of the hierarchy of controls and the 55 years since they were codified by OSHA in the United States and used around the world, this model has changed very little and has been proven effective in the reduction of exposures to hazards in the workplace and therefore the number of injuries and accidents. There are some variations on this theme. For instance, OSHA splits administrative controls into two separate sections on their hierarchy of controls worksheet, and there are versions that further break down the control methods for specific activities, for instance working at heights. But for the majority of hazard categories, the classic hierarchy will suffice. It's important to point out directly that the effectiveness of these controls decrease rapidly as the pyramid is descended. I've seen too often mitigation efforts skip the consideration of more effective methods higher up the pyramid. Most commonly, I've seen quick jumps all the way to the bottom with PPE when other methods would be more effective and in many cases cheaper and easier to implement with consistency and better results. Also keep in mind that appropriate controls for a particular hazard may, and most times will, require multiple controls all the way up and down the pyramid. Take our example of the tile cleaner from earlier. Substitution was used in conjunction with administrative controls for the use cases that led to the eye injury. Another combination of substitution, administrative controls, and PPE were used for the remaining use case where substitution wasn't feasible and elimination was not an option. But perhaps a renovation is coming up in the next 2 years. An elimination control could become viable if the tile was switched to a different surface material that's much more effectively cleaned with much milder chemicals, completely eliminating the need for the hazard altogether. Here I'll also make another very important point. Oftentimes, the easiest way to point out how well the hierarchy of control works in practice is to point them out following an incident or injury, but they are intended to prevent hazards from affecting employees in the first place. This is why these controls should be considered and EHS professionals consulted early in project planning stages and other forms of strategic planning in organizations. To illustrate this, a resort was in the process of building a new swimming pool complex, and among the many decisions that went into the planning and construction of this facility, the subject of chlorine delivery, storage, and disbursement occurred. Traditionally, chlorine is delivered by hand in barrels to a chemical disbursement room, and periodically staff needs to switch out the barrels by hand and adjust levels based on surface testing. Both operations require extensive training in chemical safety procedures and specialized PPE, adding costs and increasing risk for daily operations. In this case, chemical safety was baked into the design from day one. A closed-loop system was devised and installed that allowed for deliveries to take place from a sealed tanker outside the facility through a built-in piping system and directly into the holding tank indoors in a segregated protected room. This, coupled with remote controls for adjusting distribution levels, effectively minimized and partially eliminated the very real risks associated with chemical exposure for the average facility employee. Not only did this do wonders for employee safety, it also helped the bottom line in the long run. The number of employees requiring expensive training and PPE was dramatically reduced for the life of the facility, on top of the obvious risk management benefits. I say all that to say this. If you haven't baked this model into every aspect of your organization, or you don't go to work every day with this on your mind, start today. It's a lot easier to do in the beginning of a project, or as you start your business, or when you start work for the day, than trying to do it retroactively. Hell, it's free. Your organization can't do it alone. Recognizing and reporting hazards is everyone's responsibility, but keep in mind that there may be multiple levels of controls already in place for some hazards, and following the requirements of your facility is key to your safety and the safety of others. On top of the requirement to recognize hazards in the workplace, employers of all sizes are also required to do something about them to keep them from affecting workers. While this may sometimes feel like a drag on the organization's money and time, the appropriate employment of tools like the hierarchy of controls can create an environment that builds a much more efficient and productive workplace, and really is a good return on the initial investment. Take safety hazards and their mitigation seriously at all levels. Keep those lines of communication open and honest about hazards, and you're going to have the best time. Thank you for watching. I hope you found this video informative and that it helped you understand the application of the hierarchy of controls in a little bit more detail. If you liked the video and you like where this channel is headed, please drop a like. It really does help above and beyond watch time. Subscription to the channel is certainly very much appreciated, and I hope to see you next time in the next video. In this video, we'll discuss how automatic fire sprinkler systems work, and probably more importantly, how most of them don't work. Before we begin, a whopping 94% of those watching my videos aren't subscribed. If you like what this channel offers, please click that subscribe button. It would be appreciated more than you know. It's a small act for you, but it will mean a lot to me and to the channel. Over the years, I've worked with a number of different automatic sprinkler systems, and I'm always surprised with how they are perceived to work outside fire protection and safety disciplines. It seems simple enough. When a fire starts, water sprays out of the nozzles and puts the fire out by interrupting the fire triangle. As the diagram suggests, for a fire to be maintained, all three elements of the fire triangle need to be present and maintained at sufficient levels. You need only remove one and the chain reaction will stop and the fire will go out. Sprinkler systems act on the heat of the fire, reducing it to a level below which combustion can occur and stopping the chain reaction. As a colleague of mine was fond of saying, you put the wet stuff on the hot stuff. My first video on this channel was a case study on one of the deadliest structure fires in US history. At the end of that video, I highlighted simulations that were run by NIST that demonstrated how differently that fire would have spread if the venue installed an automatic sprinkler system. Quick note here to save me from saying the word automatic over and over again. While there are manually activated sprinkler systems for some applications, the vast majority of sprinkler systems are activated without human involvement. Keep this in mind as I'll discuss manual systems briefly as I move throughout the video. Technically speaking, there are four main types of systems: wet, dry, deluge, and pre-action. There are a lot of different ways to configure each of these systems, so we'll break them down a little bit further. My goal here is not to make experts in sprinkler design, installation, or maintenance, but more to break down the way they operate in practice, with focus on wet and dry systems as they are the most common type you're likely to find in your workplace. We'll start with a brief description of each type of system in general terms. Wet systems are systems that have water, or in some cases a wet extinguishing agent, throughout the system at all times. Take a look at a sprinkler head, and that system is described as being charged right up to that and every other head. A good way to think about it is the water faucets you have at home. Turn the handle, water immediately comes out. Dry systems are systems that are either entirely or partially devoid of liquids. In many cases, pressurized air is what you'll find first if a head on that system activates, followed by water or an agent as the air pressure is released. There are some systems that are uncharged with air or water that rely on water pressure upon activation. Dry systems are mostly installed in areas that are subject to freezing temperatures such as crawl spaces, attic areas, and unheated foyers or warehouses. Upon activation, these systems are similar to a drained outdoor faucet being turned on for the first time in the spring. If you don't live in a place that has cold winters, I'm sorry if that analogy falls a bit flat. Deluge systems are the systems most people are familiar with from TV and movies. When needed, the entire system, or every head in a zone, activates at the same time. Deluge sprinklers are applied where there is a danger of fire so high that the entire area needs to be immediately doused regardless of how large the initial incident is. This is how sprinklers are shown to activate in most produced media, usually for story or comedic reasons, but not generally how the majority of installed sprinkler systems work. Pre-action systems are designated to activate based on a specific or series of predetermined events to minimize any false activations. These types of events can be something like the detection of heat above a certain threshold and the detection of a significant smoke density, or a variety of other event detections that together meet predetermined criteria to activate the sprinklers. They're usually reserved for sensitive applications with high value or irreplaceable contents like art museums or data centers where false activations must be curtailed as water damage may be completely unrecoverable. In many of these use cases, specifically designed clean agent systems are often opted for instead of a water sprinkler system for just this reason. They extinguish fires by reducing heat in a different way or by interrupting a different part of the fire triangle with materials that leave no residue and that are electrically non-conductive, but that's a whole nother topic. The basic parts of a sprinkler system are, well, pretty basic in their overall concept. First, you need a water source. Usually the same water source as the potable water for the facility, but this can occasionally vary. Second, you need sufficient water pressure. The water pressure needs of a sprinkler system can be higher than the pressure from your water source, so oftentimes a dedicated water pump or fire pump is installed to ensure that the system can meet the pressure required for design needs. The third part is the interior piping to send water to all the zones and individual sprinkler heads, and the fourth is the sprinkler head itself. The sprinkler head is basically a nozzle and consists of a sealing assembly, temperature-sensitive glass tube, and a water deflector. The design of sprinkler heads vary depending on things like how much water they need to flow and spread pattern to ensure that the head properly spreads water over the desired coverage area. Quick note here, there are times when, for a variety of reasons, sprinkler heads are recessed. For these applications, there is a mechanism that holds the assembly in the recessed position that releases via water pressure when the head activates. Now that we've gotten the basics out of the way, I would venture to guess that you've probably never been around when a sprinkler system is activated. Most people haven't. Hell, the ones I've been a part of were exclusively due to system malfunctions, freezing pipes, or because somebody messed with it. Under actual fire conditions, this is how wet and dry systems generally work. Inside a sprinkler head, there is a small glass tube wedged between the spreader and the sealing assembly that keeps the head closed. These tubes are engineered to break apart above a certain temperature range, releasing water at the desired flow rate. So the shatter temperature of those tubes needs to be reached for each individual head for that head to activate. Heat dissipates very quickly in open air, and if the temperature is reached for one head, it is unlikely that other nearby heads will activate in the majority of cases, unless there are multiple fires or the initial head fails to extinguish the instigating fire. One of the most common misconceptions when it comes to sprinkler systems is when there's a fire, all the sprinklers go off simultaneously. And I can understand why. Heck, I've had highly educated engineers fall victim to this perception, but in TV, movies, and other media, it's generally how they're shown to work for story or comedic reasons. The majority of systems are designed to confine the water to the area or areas where the fire actually is and where the sprinkler system is needed to limit water damage. Sprinklers, if designed and maintained properly, are exceptional at putting out fires before they spread. But once the fire is out, water will keep flowing until turned off by responding personnel. This is a fail-safe to make sure that a fire does not spread uncontrollably if the building's unoccupied or has been evacuated. Sprinklers flow a ton of water. In one instance I was a part of, the sprinkler flowed so much water that it began to flood a small enclosed foyer faster than the water could run out of the drains and the door gaps. Following a fire, a large portion of the cost associated with recovery can be attributed to water damage and not direct fire damage, so you can see why limiting water damage is taken into consideration. Dry systems act in the exact same way with most of the same equipment, but in those systems there is an initial release of air out of the head as water pushes air out of the piping on its way to the open head. Let me tell you, the sound of air whistling through a sprinkler head is otherworldly, even if you're expecting it. Dry systems are installed most commonly where there is a risk of freezing temperatures. In order to retain the reliability of wet pressurized systems, this is accomplished by maintaining air pressure above the freezing line with a heavy-duty manifold to keep water down and to keep it ready at all times. This is accomplished with a small air pump that will run sporadically if the air pressure drops too low. These relatively simple, robust solutions are great for most applications. They can also be easily integrated with otherwise wet systems where appropriate for the facility. Wet systems that contain antifreeze exist, but usually require a bit more preventative maintenance over time. As alluded to earlier, there are systems that are designed to activate zones or even entire systems all at once. Deluge systems. You'll find those in very specialized applications with particularly flammable or explosive environments where even a small fire or just excessive heat with no active fire may create conditions that would be instantly catastrophically destructive if prevention methods fail. Good examples would be a system in, say, a fireworks factory or a propane tank storage facility. These types of systems are far more nervous and paranoid in their design and implementation, but for particularly hazardous environments, water damage is of least concern, so you really want to hit the whole area with water quickly and keep hitting it for as long as possible. Pre-activation systems are functionally similar to the types of systems already discussed, with their uniqueness coming in the methods of activation and the way they behave once activated. The criteria can be very customized to the specific facility, so we're not really going to go into a great amount more detail in this video about pre-activation systems. So now that we know the basics of how sprinkler systems work, how do we know where we need them or don't need them? This is where the National Fire Protection Association comes in, at least in the United States, specifically NFPA 13. The requirements set in NFPA 13 are extensive, and we're not going to go over them chapter and verse here in this video. Their application can be very different not only for different structures, but can also vary wildly based on how a space will be used, what will be stored there, how many people occupy a space, and a whole host of other requirements to ensure that the installed sprinkler system will be able to adequately meet the demands of the fire risk posed. If you're a business owner or facilities manager, for best results, contact a reputable and licensed sprinkler system design firm to help determine if your sprinklers are adequate and in good repair. There really are just too many variables to begin discussing in this video. And don't forget your insurance company. In fact, for many, starting with your insurance company yields the best results, as it is in their best interest to provide assessments for your facility. They can get you started down the road to not only a compliant sprinkler system, but one that just might reduce your insurance premiums over time. Sprinklers are mostly in the background and an often neglected but crucial piece of infrastructure for any facility. It's a lot easier than you might think to end up with a deficient or even non-functional sprinkler system if repair and maintenance guidelines and requirements aren't followed. The basic OSHA requirements can be found under CFR 1910.159 automatic sprinkler systems. This is one of the shorter standards under OSHA, as the standards and practices are found in and mainly maintained by NFPA codes. OSHA codifies these statements into law with this statement. OSHA does provide some specifics as to what's expected with regards to ensuring that a sprinkler system is operational and adequate for the hazards present. I encourage review of this standard and the entirety of Subpart L for all facilities, as it not only outlines sprinkler requirements, but fire protection requirements in general as well. Be aware, though, that there are other regulatory bodies that may also have jurisdiction in addition to OSHA. State and local fire regulations and requirements may vary, or have requirements above and beyond the requirements of OSHA. All this being considered, we'll stick with a good all-around approach along with what is minimally required. It is an excellent idea to complete monthly visual inspections of the general condition of the system, along with tracking of appropriate system pressures, the general cleanliness of the system and all of its parts, damage to the system, small leaks or ice buildup, clearance for all sprinkler heads and access to system controls, and any other issues that can be noticed that will lessen or prevent a sprinkler system from functioning properly. These are all things that can be easily accomplished with minimal training or expertise in plumbing or fire sprinkler maintenance. Regular flow testing is also required to ensure that sprinklers are functional and that proper flow rates are maintained. At a bare minimum, this should be done annually, but quarterly is prescribed by the NFPA, and a more frequent regimen may be required or desired based on the type of occupancy or the particular locality. Countries outside the United States may also have different requirements, but this video is certainly long enough already, assuming you haven't clicked away yet. I'll leave you with this video from NIST to demonstrate how these systems save lives and property. This test is simulating the conditions as investigated on the night of the fire, including building material approximations, size and shape of the room, and ignition conditions. The second test simulated the exact same room, materials, and conditions, but with an appropriate sprinkler system installed. There's no question that the cost of a sprinkler system is worth it, but just don't forget about it and expect that it will work when you need it without proper maintenance, calibration, and upgrades. As a comparison, the majority of cars sold in the world today run out their entire life cycle without the airbags ever being deployed. But when you need them, you really, really need them. So ensuring that they're ready to go at all times is in your best interest. Sprinkler systems are certainly no different. Like I said at the beginning of this video, this isn't meant to make sprinkler system design experts or maintenance folks out of anybody watching. It's really to give a good idea as to the basic components of a sprinkler system, how they work, how they're expected to work, and some of the things that can go wrong over time if not properly maintained and inspected. Really hope you found this interesting and informative. If you liked the video, please give a like. Please consider subscribing to the channel. I'd like to get off lucky number 13 if possible. I'm not a particularly superstitious individual, but 14 would be nice. Thank you for watching, and I'll see you on the next video.